let's start with a confession. You've deployed your model, traffic is flowing, and then the cloud invoice arrives. $100,000 a month for GPUs? It reads like a car payment. Here's the uncomfortable truth. Hardware and energy account for over 60% of AI inference costs. That's high bandwidth memory, electricity, and silicon devoured by every token. But here's the kicker: this cost isn't a law of nature, it's a systems-level problem, and you, the backend engineer, are the one holding the wrench. But before we touch the code, let's talk about the marketplace. Paying full on-demand price for an A200 to serve a model that spikes once a week. That's buying a Ferrari to drive to the grocery store. On-demand is flexible, but it's the most expensive way to rent compute. Reserved instances, with 1 to 3 year commitments, cut costs by 40 to 70%, but they demand steady, predictable traffic. Spot instances, cheapest of all up to 80% off, but they can be yanked away at any moment, only for fault-tolerant batch workloads. The winning strategy? Don't marry one. Use on-demand for spikes, reserved and spot for your baseline. Never let a GPU sit idle at 5% utilization. Now the real meat: the software. This is your primary cost lever. First, quantization. Most models are born in FP32 32-bit floating point. That's like writing a novel where every word is in 48-point bold font. Quantize to INT8, and you shrink the model footprint by 75%. Less memory to shuffle means less energy per token, and memory bandwidth is the true bottleneck, not raw flops. Second, distillation. Instead of deploying a 175 billion parameter behemoth to answer simple queries, you train a smaller student model to mimic the teacher. Less memory, less compute, less energy on every level. Third, dynamic batching. GPUs are party buses, they want to be full. By grouping incoming requests into concurrent batches, you amortize the model load and maximize hardware utilization. Combine all three: smaller model, smaller footprint, fuller GPUs, and you pushed cost reductions past 40%. Here's the equation that governs everything. Total inference cost equals hardware efficiency times utilization rate times software efficiency. This is multiplicative. If you buy the cheapest spot instances but run an unoptimized FP32 model with terrible batching, you're just trading one problem for another. The industry leaders OpenAI, Uber, Grok combine all three. They use serving frameworks like TensorRT for NVIDIA's Layer Fusion, ONNX runtime for portability, and VLLM's paged attention to eliminate memory waste in the KV cache. So the next time you deploy a model, don't ask is it fast, ask is it cheap to run at scale? Ask what's my cost per 1,000 tokens, because a penny saved on a token is a penny earned in the cloud.